Here we introduce measures that can be used to compare values from different data sets or to compare values within the same data set. These are called measures of relative standing. The most important measure of relative standing is the z-score. The z-score, otherwise known as a standardized score, is the number of standard deviations that a given value x is above or below the mean. Mathematically, the z-score is given by the two formulas here. One is written for population, one is written for a sample. X is the data value. You're going to subtract the mean and divide by the standard deviation, whether you're dealing with population or sample. So to find z, you'll take the data value, subtract the mean, and then divide by the standard deviation. Couple of notes down at the bottom. When rounding the z-score, always round to 2 decimal places. So that's an always, no exceptions. Z-score always gets 2 decimal places, and make sure you round correctly. When the data value lies below the mean, the z-score will be negative. That's the second note. So we have an example. Suppose student A takes a standardized test, and that test is test A. He scores a 65. The test is designed so that the population parameters are mu equal to 50 and sigma equal to 10. Student B takes a different standardized test, test B. She scores a 29. Test B is designed so that population parameters are mu equal to 20 and sigma equal to 5. Which student has the better test score? So we need to find the z-score for both exams, A and B. Once we know the z-score, we can compare the two z-scores. Whichever one is the highest indicates the higher test score for the students. So, for test A, z is the data value, he scored a 65, minus the mean, which is mu, and then divide that by the standard deviation, which is 10. So that's simplified as 1.5. Test B, she scored a 29. The mean there is 20, and sigma will be 5. So simplifying that, we get 1.8. Now, we have found the two z-scores for the problem, but we haven't answered the question that was asked yet. The question that was asked was which student has the better test score. The one that has the better test score has the better z-score. So 1.8 is higher than 1.5. So exam B is the better test score, or student B has the better test score. Again, we have the same type of problem with student A and student B, except the scores are different this time. He scored a 63 and she scored a 25. Again, they want to know which one is better. So we'll have to do that same comparison. Take the mean. Test A, he scored a 63. Data value minus the mean. Divide by the standard deviation. Test B, she scored a 25. Subtract the mean. Divide by the standard deviation. So simplifying the z-score for exam A, that is 1.3. Simplifying the z-score for exam B, that is 1. 1.3 is greater than 1, so exam A, or student A, had the better test score in this scenario. Always make sure that you answer the question completely. Just because we did the comparison doesn't mean we had answered the question. We had to note that exam A, or student A, had the better test score.